Hello everybody, Mr. Chan here. I'm presenting a lesson for Algebra 2, 1-3 Piecewise Defined Functions. If you can turn to page 9 of your note takers, we'll get started here. All right, we have an opener. It says a music teacher needs to buy guitar strings for her class. At store A, the guitar strings cost $6 each. At store B, the guitar strings are $20 for a pack of 4. We have a couple of graphs here. Make graphs that show the income each store receives if the teacher needs 1 to 20 guitar strings. Let's go ahead and label the axes. Take a few moments. We'll start with 8 for both of them. And in terms of cost, this might be a great time to kind of guesstimate how much it would cost. If there were 8 strings, how high do you need to go? Maybe go by $5 increments. So let's do that. Every increment is 5, 10, 15, 20, and so on. That works. The horizontal axis is the strings axis. And the vertical, of course, is the dollar amount. I'm going to do the same with the other graph as well. Get that going. And my vertical is the same, dollar amount. All right. For the first store, each string costs $6. One string, $6, 2 strings, 12, and so on and so forth. I'm going to plot them right now. All right. I might as well put in 0, 0. And I'll do the same for the other store. A 4-pack is $20. Okay. 8. Now, we have to kind of think about how much it costs individually versus a 4-pack from one store to the other store. Forgot to label store A and store B. Each individual string in store A is considered to be discrete values. In store B, the packs are all together. You can't buy individual. Even if you needed 1 or 2 or 3, they will cost you $20. To show that, I'm going to line up right there my packets for a 4-pack. Notice with 0 strings, I left an open circle. I'm going to do the same thing up here. Whoops, wrong color. So those represent a packet of 4. This is called a step function. It looks like steps that you might take in a building going upstairs. These are called step functions with discrete values. Okay. Describe the shape of the graph for store A. Describe the shape of the graph for store B. What are the graphs? How are the graphs different? We kind of mentioned that already. So I'll list that here. Store A. There are basically those points, those discrete values, follow a linear function. They plot a line, basically. Whereas store B are step functions. Compare the graphs, moving on to the next question. Compare the graphs for store A and B. For what values of guitar strings is it cheaper to buy from store B? Well, we got to look at the 4-pack. That was $20. For the other store, a 4-pack was more than $20, wasn't it? That was $24. Oh. So I would say at 4 strings, it's cheaper. Let's write that down. For store B, arguably, you might say that with the 7th and 8th strings, it's cheaper with store B as well. So let's note that. The 7th and 8th strings in the other store are much, much higher than $40. There's a habits of mind question at the bottom. Why do you use dots rather than line segments to graph these two functions? Well, it's simply because strings are integers. They don't come in fractions or decimals. Those are those discrete values. Cannot be connected. Happen to be positive integers. Positive integer values. Next page. And if you're following along in the textbook, we're on page 23. In fact, I am going to talk about the actual data in example 1 on page 23. Alani has a summer job as a lifeguard. She makes $8 per hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 per hour, for each hour over $40. 40 hours, my bad. So let me write that information down here to kind of summarize what I see in the book. Alani makes $8 an hour. And up to 40 hours. Anything over it's considered overtime, time and a half, which bumps it up to $12 an hour. Write that down. Question: how much will Alani earn if she works 37 hours? Let's draw some quick graphs here. Versus if she works 43 hours. I'm going to generically use the horizontal axis for time and use the vertical axis for dollar amount. Now at 40 hours, if you multiply 40 times 8, you'll get $320. So let's call that right there. This point right here. At $8 per hour. And if you think about it, every hour below 40 hours is linear from 0 hours to 40 hours, giving you $320. But the nice thing, keep that in mind, 37 hours, let's go ahead and multiply that, times $8 an hour. Let's see, 56, carry the 5, 24, 296 bucks. Nice. What if she works 43 hours? Well, you have to understand, not all those hours are at $12 an hour, time and a half, only the additional hours beyond the $40. So we need to separate the 43 to 40 plus 3. First 40 hours is at $8, so I'm going to multiply that. And the additional hours is at time and a half, $12. So there's your setup right there. 320, which we have in the graph. We kind of jumped the gun a little bit to see what the maximum is for before going overtime. And 3 hours at $12 an hour is $36. So that'll give us $356 in total after adding the first part and then the second part. And I'll draw the time and a half. It's almost like the slope just increased by 50%, didn't it? Any questions by example 1? I think for this lesson, we will just focus on the first 3 examples. Anything extra, I would highly recommend you look at the textbook because these do take a lot of time. All right, we did do some piecewise functions the first couple of days of school. Now we're going to try to attempt to do it here. For example, 2A and 2B. Wow, there's a lot going on here. Let's go ahead and set this up. Let's draw some axes for 2A. And also 2B. Oh, that wasn't the best in the world, was it? All right, close enough. Look at the first function, f of x. F of x equals to 3 separate pieces. We're going to color code them. Red, green, and blue. Each of the functions, the pieces, have restrictions on the domain. The first piece is between -6 and -2 inclusive. When I say inclusive, I'm saying at those edges, those endpoints, they are closed circles. Let me zoom in a little bit so you can see a little bit better. This is closed, and the other one is also closed, both of them. So go to their domain along your x-axis there, and we're going to go by 2's. So 2, -2, -4, -6, and we're going to -2. I call restricting the domain as if we're creating force fields. See what I'm doing right there? I'm limiting my graph of 2x plus 5 between those two orange force fields between -6 and -2. 2x plus 5 is a linear function, mx plus b, so that's pretty easy. The y-intercept is 5. Let's go to the y-axis. Remember, these are by 2's now. And I'm going to put a y-intercept of 5 and the slope of 2, up 2 over 1. Now, I haven't connected anything yet. Those red dots represent that line, and if you are connecting them, that means you are ignoring the restriction on the domain. It must be between -6 and -2, so I'm going to connect those ones between -6, where it intersects the vertical force field, and -2. Connect those dots. That's my first piece of the piecewise function, and the endpoints are closed. Second piece is a parabola between -2 and +1. We already have -2. I'm going to go ahead and draw in a vertical force field at 1. And this parabola, trust me, 2x squared minus 7, if you graph it on a calculator or on your cell phone using a graphing app, it will look like this, trust me. And before we graph it, note that the left side is open and also the right side is open. They're both open. In fact, some teachers might have you plug in -2 into the function, 2x squared minus 7. We can do that really quick. -2 squared is 4. 4 times 2 is 8. Minus 7 is 1. So interestingly enough, it connects exactly at that point right there, -2, 1. Then it does a little hook. Let's plug in the other point, 1. Those are the two endpoints of the restricted domain. 1 squared is 1. 2 times 1 is 2. 2 minus 7 is -5. So it goes to here. Whoops, make that open. So this is an actual parabola that opens up because A is positive. Remember that from Algebra 1. And when you connect it, it goes like this. Bam. Very cool. Let me make that a little better. I believe the vertex, if I would recall, is just below the -6 area. There you go, much better. I went a little too shallow there on that vertex area. All right, that takes care of the second piece. The endpoints are open. They're part of a parabola. Let's try the last one here. The last one is between 1 and 3. So I already have 1. Let me go to 3. Along my domain. So that little sliver, I have to fit -4 minus x into there. -4 minus x is kind of written backwards. So I'm going to rewrite that. So it's easier to interpret. -x minus 4. That means the y-intercept is at -4. Let's put a dot there. And the slope is -1. Oh, very cool. Look at this. I'm going like this. Now, do I need to connect all those blue dots? No. And these blue dots intersecting the vertical force fields are closed on the ends for both of them. Okay? They're both less than or equal to. So, in fact, those blue dots do intercept the open circle of the parabola. Interesting. So this is closed. Connect the blue dots to here, closed. Okay? All right. Woo! This was pretty crazy there. They're asking for the domain and range. Let's give it to them. The domain are all the x values. And it's kind of stuck between -6 all the way to +3. So the domain of all values of x such that x is between -6 inclusive to +3. There you go. The range are all the y values. It looks like that the lowest y value is, let's see, let's count, let's see, let's red. Yeah, it looks like it. -2, -4, -6, -7, including it, all the way to the highest point up there. Definitely looks like a +1, the high y point. Okay. All right. So don't forget about interval notation. We might as well practice that too. This is also known as, for the domain, bracket -6, 3. And this guy down here for the range is bracket -7, 1. Okay? Good practice. One last thing they're asking us, we're not finished yet. We're asking to see which interval is the function increasing or decreasing. That's a lot of information, right? Thrown into one problem here. Let's do that. Increasing, like a roller coaster from left to right, and decreasing. A lot of information here, okay? Oh, the first piece is increasing, sweet, from -6 to -2. Let's just try interval notation. So this is the from left to right, like a roller coaster. And I'm going to use just interval notation. It just seems to be faster sometimes. It really is. And increasing is easy. That first red piece right there. And that's from -6, including, whoops, wrong color, to positive, I'm sorry, -2. And that's closed as well. Comma. Let's take a look at the other pieces. Oh, look, part of the parabola is increasing from the vertex to 1. So I'm going to just focus on half of it. Now, remember, the vertex is neither increasing or decreasing at that low point in the green graph. So I'm going to use parentheses to represent it starting from there, but not including 0. Up to, now the green ends at a open circle, so you don't include it for increasing. Yeah, there it is. Decreasing, that's pretty straightforward. Look at the green, it's going down from -2, not including -2 though, to the vertex 0. And then it's decreasing the last piece from 1 to 3, but those are endpoints are closed. So I'm going to use brackets. Yes. See why that I'm not going to do the whole lesson. This alone took a while. Well, that takes care of 2A. I'm going to go and tackle 2B with less talking and see if you can follow along. Same colors. Looks like this time we have 3 linear functions. And the first one seems a little bit interesting, different. It happens to be a horizontal line. This time I'm going to go by 1s. It's not necessary to go by 2s. Great. And I'm going to go and highlight the force fields. There they are. It's kind of nice sometimes with these note takers. It seems like a lot of times they throw in the harder problem first out of the 2 A and B, and then they throw in the easier one second, which is fine by me. The first one is a horizontal line at +3. That's basically y equals 3, everybody. That's y equals 3. All right, let's go to y-axis there. There's my 3. But I'm not going to color the whole thing. I want to draw a horizontal line between -4 and -1. Now, at -4, this is open. At -1, it's closed. So be aware of that. So imagine a horizontal line. Notice I'm kind of putting dots along 3, but I only need to connect between -4 and -1 with an open circle, all the way to a closed circle over here, and connect the two. There they are. Yay, that's it. Second piece. I have an equation of y equals -x plus 0, technically. Y-intercept is 0, slope is 1/1. I didn't have to draw all those green dots, excuse me, but I want to connect between 0 and 2. Those endpoints are both closed. Interesting. So from here to here, whoa, those are closed circles. These are definitely disjointed. They're not connected with each other. Next piece, 3 minus x looks kind of funny. I'm going to put it in mx plus b form and make it -x plus 3. Its y-intercept is +3. Great. Its slope is -1/1. And this time it's between 2 and 4 with open endpoints. So between 2 and 4, those vertical force fields, I'm going to have open circle between those blue dots that fall between 2 and 4. Let's describe the domain. The domain is basically the restrictions up there. Let's just list them. Let's do it. Do you mind if I just go to interval notation to make life easier? Let's see, parentheses, -4 to -1 bracket, comma, then from 0 to 2, bracket, and finally from 2 to 4, parentheses. There we go. Da, 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 da. Yep, that looks good. Range are all the y values. I've got to be careful here because I noticed one of my y values is just a 3. I might have to just use the comma with that one. So let's just imagine. Notice that from the lowest point, it's -2 bracket and we're going to go up, and it covers the -1. So there's overlap between the blue and the green graph vertically, and it'll stop at +1 right there. That's +1. This is -2. So I'm kind of looking at this portion right here going upwards, and I'm going to describe it with 1 parentheses. That yellow highlighted region going upwards is between -2 and +1 non-inclusive. And then we have the 3. And I think I'm just going to list it like this. The y value of 3. Isn't that kind of weird? Because it's just a single line. Huh. Let's talk about increasing and decreasing. All right, let's go from left to right. Oh, look, the first segment is neither increasing or decreasing, so that's true. And the other 2 segments are not going up at all. So here, nothing is increasing. That's part of the graph, so just none. Decreasing, on the other hand, is the last 2 segments. So I need to list the domain. From 0 to 2, it's going down. And also from 2, not including 2, to 4. Technically, you can argue that these 2 can be combined together from 0 to 4, like that. All right, let's keep going. I'm going to go ahead and skip this question right here and jump to the bottom. All right. Ah, very good. We're going to go ahead and go backwards and write an equation for those pieces for the piecewise function. Since there's a lot of room on the left here, I'm going to go ahead and do 3a and call that function 3x. I'm sorry, f of x. All right, here we go. Put a big curly mark there. Identify your force fields. Let's see. That looks like -5, I believe. Sure. This one, of course, is -2. This one right over here is 3. And this one, they're not connected. This is 4. And of course, this one right here is 6. There are 3 pieces, of which only 2 of them are connected. The last piece is not connected. I'm going to go ahead and write down my inequalities. Now, it's going to be hard to tell whether this part right there that's connecting the 2 pieces are open or closed. I'm just going to assume they're closed to make life easier for myself. So for the first function, it's a horizontal line. That horizontal line crosses through 7 along the y-axis. So that's going to be f of x equals 7, and it's stuck between -5 and -2. I like to have my students write the lowest number on the left, the letter x in the middle, and -2. It's ready for a compound inequality. Both ends are closed circles, so I'm going to do that. Yay, those are closed. That's my red dotted line there. Second one, let's do this one. Sometimes you want to extend it, see how things are going. Obviously, it's has a negative slope, and it looks like it crosses the y-axis at +5. Oh, interesting. So the slope looks like it's going down 1 over 1, down 1 over 1. Yep, it looks like it does. So I'm just eyeballing it. I'm not going to write an equation. That's just too much work. But the slope is definitely -1x plus 5 because it's crossing the y-axis at 5. And that piece right there is between -2 and +3. Again, I don't know if that's an open or closed circle at -2, so I'm just going to assume it's closed. It doesn't matter, actually. And at 3, it's definitely closed as well on the endpoint there. Yay, not bad. So just to remind you, those inequalities there could be open circles or closed circles, but they have to be one or the other in order to fill in with each other. They can't be both open though. One of them has to be closed at least, but we don't know if they're one open, one closed, or both closed. All right, third piece of the puzzle. Oh my gosh, this one's crazy. I'm going to connect the dots, let's see, down 1, 2, 3, 4 over 2. Interesting. 4 over 2. Ah, so I'm kind of eyeballing to see where this is heading. So please forgive me right there, right there. That looks good. For the third piece, again, I'm being kind of lazy here, not using actual formulas to find the slope of the line, but I'm seeing that the slope of the line is up 2 over 1. I see that. It's 2x. And it crosses the y-axis at -3. Man, I hope that's right. I think it's right. All right. That last piece is between 4 and 6. At 4, it's an open circle. So you only need less than. And at 6, it's a closed circle. Congratulations, you've just created a piecewise function based off of a graph. I want you to try 3b by yourself. If you get stuck, look up. I'm going to do 3b quietly. So, how are we doing out there? I found my force fields already. All I'm doing now is writing the equation for the first segment, which happens to be a line that crosses the y-axis at 0, and it looks like it has a -1/1 slope. And it's between -3 and -2. Whoops, what's going on there? Let's see if they'll come back. I'm writing a restriction on the domain right now. On the left side of the segment, it's closed. On the right side of the segment, it's open. Yay. Second one. Horizontal line crosses 1. That's pretty easy. That horizontal line, the second piece, is between -2 and 1. On the left, it's closed at -2. On the right, it's open at 1. Hey, this is pretty easy so far. This is the last one. Let's do it. Well, that darn slope is kind of scary. Down 4/1, down 4/1. Looks like it crosses the y-axis at -5. Slope is 4x minus 5. And it's between 1 and 2. And the endpoints are closed. Woo! I'm going to stop because those problems took a long time, didn't they? I challenge you to do the last page of the note taker and bring it in, show it to me. But we can skip example 4 and example 5. Those we've kind of done already a few days ago in our opener. But I challenge you to try 6, 7, 8, and 9 and bring it in. But anyway, I am finished. I want you guys to know that if you have any questions, I'll be happy to help out. Have a nice day. Talk to you later.